Good afternoon. Hi, this is from Dr. B. Kumar, HOD of Physics, SNS College of Engineering. Today we discuss the topic of laser and fiber optics. The subtopic of this unit is principle and propagation of light in optical fiber and numerical aperture acceptance angle. This is all the property we have discussed from today in optical fiber. So, first of all, what is optical fiber? Then, why we used in optical fiber in a different application in day-to-day life? For example, of engineering, medical, and industries like that. So, we think about what is a optical fiber, what is a principle to be act in optical fiber, and how the light will be communicated in a optical fiber. So this is all the question we think in the starting of this session. Then the end of session you become very clear of this question to learn the answers. So the introduction of optical fiber. The optical fiber is a insulating material. It's formed in a very thin layer to communicate the signal for using in a light. So the optical fiber is one of a cable. So the light become communicated in the audio, video or text messages to the conversion of the different signal wise. It become communicated in one end to another end. To form of without any losses or intensity. So the principle of optical fiber is a total internal reflection. So the total internal reflection is only to be formed in the optical fiber. That way we used in a communication system. So the total internal reflection to based on some condition of light to be applied and propagate off in a optical fiber. So first one, the light must be travel in denser to rarer medium. Then second one, the angle of incidence is greater than critical angle. So this too is a condition for total internal reflection. So this total internal reflection is a principle of optical fiber. Then this is a structure of optical fiber. The inner is core, then outer is a cladding, then outer surface of cladding is a buffer jacket or protective jacket to the form of PVC. So the light must be allowed in core, the light only to be propagated in a core. It's not transmit in a cladding because the refractive index of core and cladding it become entirely different. So the slightly change of the refractive index is not allowed from in a cladding. So based on the total internal reflection, the core and cladding to the form of this transmissions. It depends on the core radius, the numerical aperture of the core is very important, and the wavelength of light stimulating of the optical fiber is also to be important. The numerical aperture is defined as the sign value of acceptance angle. So what is acceptance angle? The light gathering efficiency of optical fiber, it's called as an acceptance angles. So the theta A is called as an acceptance cone, right? The acceptance angle is based on the incident ray of optical fiber. So this is all the derivation we followed from to find of numerical aperture and acceptance angle. It based on the principle of Snell's law. The Snell's law, we know that the refractive index is equal to sin I by sin R. The sign value of angle of incidence by sign value of angle of refraction. So based on that principle or law, we followed from this formula to derive from Na. So the two points to meet at in a optical fiber. The one is a point intersected in a incident ray, and another one is in a the meet at in a core cladding surface level. So the 2 points we have get 3 refractive index. The one is in a outside of optical fiber. Then another one is in a meet at optical fiber in a surface of induced ray. Then another one is in a reflection mode. So the 3 refractive index in air, refractive index in core, refractive index in cladding. So the n naught sin theta equal to n1 sin theta 1. So we know that in mathematical formation the cos theta 1 equal to sin theta 2. So the n2 by n1, the sin x equal to root of 1 minus cos squared x. So the sin theta 1 equal to root of 1 minus n squared 2 by n1 squared. So the n naught we consider is 1 because the n naught we consider is a refractive index of core. So the refractive index of core, it become 1, we get the sin theta naught equal to n1 root of 1 minus n2 squared by n1 squared. The numerical aperture is equal to root of n1 squared minus n2 squared. So the n1 we know that refractive index of core, n2 is a refractive index of cladding. Then parameter of optical fiber we discussed in based on that formula. So the acceptance angle, that is a theta naught equal to sin inverse root of mu1 squared minus mu2 squared. The acceptance cone equal to 2 times of acceptance angle. So the numerical aperture NA equal to sin theta naught equal to root of mu1 squared minus mu2 squared, or n1 squared minus n2 squared. Then the addition of property we discussed in that the optical fiber is skip distance. So the losses LS is form of D. D is the diameter of the core, because that is a very important in a propagation of light in optical fiber. The root of mu1 by mu naught sin theta 1 whole square minus 1. The number of reflection NR equal to 1 divided by the skip distance. Then acceptance cones. This is a clear picture to be shown in that acceptance angle, also in acceptance cone. The center axis we call this a optical axis. The acceptance angle is an incident angle to maximum at, that is acceptance angle. Then the two side of optical axis to form an angle, that is called as acceptance cone. This is an imaginary formation. So the cone associated with the angle 2 theta is called as acceptance cone. So the theta not equal to sin inverse root of mu1 squared minus mu2 squared. Then this all the property based we have used in the application of optical fiber. The optical fiber we used in mainly in communication system. The communication, the signal become communicated in one end to another end to the form of transmitter to receiver. In between the waveguide medium is a optical fiber. So the optical fiber, it become communicate the light signal without any losses. The outside it forms some losses to change of the signal. Then we have amplitude the signal, finally we get the same signal. So the inside of the transmitter we applied in analog, and outside of the receiver we get from analog. So the signal, it become the same input and output, the almost same values to get in the output of the efficiency. So this is a very good waveguide medium, because it's an insulator, it's not affected in an external property. That's why we used in a rare place communication system. For example, high hills, fog areas, then underwater communication system for using in a submarines. So this all is optical fiber cables. Then nowadays the underground cable is also to the optical fiber cables. So the mainly this cable become used in communication system. The next one, the medical purpose. The medical purpose is also to the used in some bloodless surgery cables, right? The tool of surgery we used in this types of cable to be communicated. The next one, the indices side, the most of is communicated in a short or longer communication system we used in optical fiber. So this fiber is very important role to be active nowadays. So the real-time application is more and more advantages from this cables for using in that the communication system. So this all is a reference. I prepared the PPT of the optical fiber introduction and the propagation and communications of the system. Thank you very much. We discussed in another one topic from the optical fiber in next video. Thank you.